If I draw the same, this one is about a apogee and perigee in orbit raising. We are learning, and there are the launch steps. That is the first step on parking orbit, step 2 GTO, and step 3 georbit. And then we have the two different methods. Method 1 is about a perigee and apogee. We consider method 2 again a perigee and apogee. What are the various values of this perigee and apogee? Now, in the case of method 1, first step we have a perigee of a 250, apogee is a 1000. Okay, so perigee is of a 250 means what? We consider here the earth now. Okay, we consider here earth, and perigee means what? That will be nearer. So this is a nearer now. Okay, this one is about a perigee, and this one is about the apogee. This perigee is about 250 and apogee is about 1000. And then in the next step 2, it is in a geotransfer orbit. Then apogee, this one is a fixed now. Okay, in the next orbit we can consider that 250 and 360. And this one is a fixed. Only this will be changes. This one is about a 36,000. And in the next, this perigee, this one is about the apogee here. In next case, okay, so this it will transfer from what? 250 to 36,000, 36,000. So likewise, so it will be a circular one. It will be in a circular one. So it will be transferred directly to the whichever the length is there, that is in a circular fashion. So that is about a method one. In another method, in a method here, two here, we say that perigee 250, apogee 1000 now. I'll draw here again. This one is about the earth now. The perigee, we say it is about 250 and apogee is about 1000 kilometer. Then, then what? Then perigee will be 1000 and apogee will be a 36,000 kilometer. Okay, perigee will be 1000 means in the next case this will be a perigee. Okay, likewise. So this will be a perigee and apogee will be far out. And another case, this one becomes a 36,000 kilometer. And then next case, we can say that this is becomes a circular orbit. That is about a geotransfer orbit. So here in these two different cases, we say that this one is about a low Earth orbit, then geotransfer orbit, and then geoorbit. But in the case of that, we move from perigee to the geoorbit. Okay, from 250 direct through 36,000 kilometers. And here we are changing the interchanging the perigee and apogee. Okay, that is about the two different methods for showing that how that orbit ranging is done there. Okay, that is about our model here, and we can consider in a model one we see that how this vehicle to be launched there. And again, one more topic will say that a typical launching sequence of a communication satellite. We'll just go ahead for the typical launching. So generally, how we can use this launching sequence or acquiring that particular parking orbit. To acquire that particular parking orbit or to transfer your satellite in that particular orbit, so how much time is required for the launcher vehicle to place your satellite in a given particular orbit? So we consider here, okay, this one is about how much time is taken by this particular satellite to be launched, okay, or communication, whatever the sequence we are using for launching the vehicle. So right now I just try one diagram and we'll see that this about 0 minute we can say one. Just draw here one. There is a small one, then two, and there is small little bit variation in this particular direction. Then three. Okay, just tilted here, and then we have the fourth here. This one is about 4, and then we have a fifth here. And that minute we require for each and every 5, everything is to finish in a 10 minutes there. And for this particular 4 here, so it is to finish in a 15 minutes. And then likewise we have a 20, 25, 30, 35. Okay, likewise that minutes required. And according to that, we are getting the altitude of what? A 40 kilometer. So in between, you can say 80 kilometer, then 120 kilometer. Okay. So likewise here we have this one. 4 is nothing but what? Approximately, we can say that it is about a 200 to this 240 kilometer. Likewise, this is about a height. Means in general, what happened that about the event, that is about a zeroth event, that is about a vertical lift. Okay, so you can say that zero event, vertical lifting here. Okay, so we can say that takeoff likewise, or we can say that vertical lift off here. And then in the one, we say that a guidance system being tilting rocket toward the east direction, tilting rocket towards east direction. Okay, that is about a sequence then. And then what happened that the satellite has launched. Okay, that whatever the stages we have at the point two. Okay, that first stage drop, that will be of the dropping of the first stage. And in the third here, we can say that the second stage ignition started, and then fourth we have the horizontal insertion into parking orbit 185 to 250 kilometer. And then fifth is nothing but what? We can say that it is used to what? That second stage and third stage that fired at equator to acquire whatever the transfer orbit. That is about the stages. Means we say that initially that is about one, it's from lift off here, then guidance system tilting the rocket, that is about one. Then it will be okay, we can add a two, first stage drop. So that's why here is a small tilt in a 2 and 3, that small tilt. And then it will go. Then you can say that second stage ignition started at this particular 3 here. Then it will be what you can say that a parking orbit. And then we can move from this whatever the acquired transfer orbit. Okay, required transfer orbit. So if you draw the sequence here, that is about that event of a particular satellite and Earth here. So what happened? This one is about your Earth now. We can consider this about a equator now. And from this, your satellite is to be launched in the given particular orbit. So you can say that position here, we will consider it is just like a launching the satellite. Okay, this one is about a launching the satellite. This one is nothing but what we can say a parking orbit, and then it will be moving towards. Okay, we can consider here the same, right? This one is again the same here, and then it will start moving a circular orbit. Okay, this one is a circular orbit. This is about, you can say, a geostationary orbit. So how this satellite will rotate? So this one we can say a parking orbit. This one we can say it is about a geotransfer orbit, or you can say a transfer orbit. And this particular orbit is called the geo orbit. Okay, this way we can say that a launching of a satellite, or injection into a transfer orbit, or we can say that launching of a satellite in the particular position there. Okay, that is about a geostationary satellite. So that is about, that's all we can consider for this launching windows and all. So we can consider while launching the satellite. So what are the various factors to be considered for this launching vehicle? Okay, so what are the particular uh, height or particular that altitude is to be achieved? So what will be the eclipse at that particular point, when we can say that when we launch the satellites and all, what will be the eclipse durations and all, that is to be considered. And then we need to be consider that axis of the earth station and that particular satellite there.